You take an electron from your body, put it under a microscope powerful enough to see it. Mass 9.109 times 10 to the negative 31 kilograms. Charge negative 1.602 times 10 to the negative 19 coulombs. Spin 1/2. Now take an electron from a star dying 14 billion light years away. Same mass, same charge, same spin, down to the last decimal. Not similar, identical, not close, the same. Every measurement you make, energy, magnetic moment, every quantum number, matches perfectly. Two particles separated by the width of the observable universe, and they are indistinguishable in every possible way. How? Why? What makes every electron in existence a perfect copy of every other electron? And does it mean something stranger than you think? Otto Stern and Walter Gerlach heat silver in an oven. They vaporize atoms, send them through a magnetic field with a gradient. Classical physics says the beam spreads. Quantum theory says it splits. February 8th, 1922. Gerlach looks at the detector screen. 2 spots, not a spread, not 3, 2. The beam is divided into exactly 2 paths. Silver atoms deflected either up or down, nothing in between. Stern writes that tonight he still has objections to the beauty of quantum mechanics, but she is correct. The experiment submitted March 1st, 1922, proves space quantization exists. What they do not know yet, what will not be discovered until 1925 by George Uhlenbeck and Samuel Goudsmit, is that they have found electron spin, an intrinsic property, not orbital, internal. Every electron spinning at exactly 1/2 the reduced Planck constant, forever. The silver atom they tested has 47 electrons, 46 arranged symmetrically, contributing nothing to angular momentum. The 47th sitting alone in a 5s state with orbital angular momentum of 0. That electron's spin, just that spin, splits the beam. They expected 1 spot or 3 based on orbital states. They got 2. Proof that something else exists, something that does not depend on position or momentum or any spatial degree of freedom. Spin, a purely quantum property with no classical equivalent. This script is researched and factual, using sources from Physical Review journal articles published by Einstein, Podolsky, and Rosen in 1935, and from the Israel Journal of Chemistry volume 63 published June 28, 2023, documenting the Stern-Gerlach centennial with original experimental notebooks and correspondence from Otto Stern, archived at Bancroft Library, Berkeley. Now back to the information. Pauli studies the anomalous Zeeman effect, spectral lines splitting in magnetic fields in ways the Bohr model cannot explain. Late 1924, he makes a leap. He proposes a 4th quantum number, not orbital, not related to position, a 2-valuedness, not describable classically. January 1925, Pauli announces the exclusion principle. No 2 electrons in an atom can have the same 4 quantum numbers, principal number, orbital number, magnetic number, and this new one, spin. Each electron must be in its own unique state. Other possibilities are excluded. Pauli gets the Nobel Prize 1945 for this work, nominated by Albert Einstein himself. The principle explains why helium has 2 electrons in the 1s shell with opposite spins, and lithium needs a 2nd shell for its 3rd electron. Why the periodic table has the structure it has. Why matter is stable at all. But Pauli remains unhappy. He cannot derive the principle from other laws. He cannot explain why it must be true. He knows it works, but not why nature demands it. Fermions, particles with half-integer spin like electrons, protons, neutrons, quarks, must have antisymmetric wave functions. Bosons, particles with integer spin like photons, gluons, have symmetric wave functions that do not flip. The mathematics is clear. If you write the wave function for 2 electrons in the same quantum state and apply antisymmetry, the wave function equals negative itself. The only number equal to negative itself is 0. The wave function vanishes. The state cannot exist. This is not a suggestion. This is how the universe works. Electrons obey Fermi-Dirac statistics discovered by Enrico Fermi in 1926. The statistics say electrons behave as if they repel each other even when they do not interact. Bosons obey Bose-Einstein statistics developed by Satyendra Bose and Albert Einstein in 1924 and 1925. Bosons do the opposite. They cluster into the same state. This is why you can have a laser with countless photons in the same mode. This is why you cannot have 2 electrons in the same orbital unless their spins point opposite directions. You can only say an electron. Classical mechanics assumes you can track particle trajectories through phase space. Paint one red, paint one blue, follow them. Quantum mechanics says no. The uncertainty principle discovered by Heisenberg in 1927 forbids knowing position and momentum simultaneously. An electron does not have a definite position between measurements. It has a wave function giving probability. As time passes, wave functions spread and overlap. Once they overlap, you cannot tell which electron was where. The particles become indistinguishable, not because of experimental limits, because the universe does not distinguish them. The value? Negative 1.001155965218 times the Bohr magneton, the electron G factor, 2.00231930436092. The digits in parentheses denote measurement uncertainty in the last two digits at 1 standard deviation. This is the most accurately measured physical constant at the time. In 2023, Gerald Gabriels's group at Northwestern University measures the electron magnetic moment with 0.13 parts per trillion accuracy, more than 3,000 times more precise than measurements of the muon. The value matches quantum electrodynamics predictions exactly. Now take any other electron, measure its G factor, same number, every time. Electrons, halfway across the universe, measured by different teams decades apart, give identical results. Not approximately identical. Identical within measurement error. Every electron ever measured. Same mass. The charge? Negative 1.602176634 times 10 to the negative 19 coulombs. Robert Millikan measured this in 1913 using oil droplets in an electric field. He found charge always came in multiples of a single elementary unit. That unit defines the electron's charge. Every electron carries exactly negative 1 times the elementary charge. Protons carry positive 1 times the elementary charge. The ratio between proton and electron mass, 1,836.15. Astronomical measurements published in Physical Review show this ratio held the same value for at least half the age of the universe, 14 billion years. No drift, no variation. Wheeler says, I know why all electrons have the same charge and the same mass. Feynman asks why. Wheeler answers, because they are all the same electron. He explains, suppose the world lines we draw in space-time do not only go forward in time, but loop backward. One electron tracing a tremendous knot through all of space-time. When you slice through that knot at a fixed moment in time, you see many world lines. Each one looks like a different electron. The sections moving forward in time are electrons with negative charge. The sections moving backward in time are positrons with positive charge. One particle, multiple appearances. Wheeler suggests this explains perfect electron identity. They are all literally the same particle at different points in its journey. If electrons and positrons are the same particle going forward and backward in time, there should be equal numbers of each. The universe contains far more electrons than positrons, more matter than antimatter. The theory predicts balance. Observations show imbalance. Wheeler speculates maybe the missing positrons hide in protons. Unconvincingly, the hypothesis never goes anywhere as physics, but it impacts Feynman deeply. He takes seriously the insight that antiparticles can be represented as particles moving backward in time. He builds this into his path integral formulation of quantum mechanics, the work that wins him the Nobel Prize in 1965. In his Nobel lecture, Feynman credits Wheeler for the observation that positrons could be electrons going from future to past in a backsection of their world line. The one-electron universe remains a thought experiment, not a theory. No one pursues it. But the question it raises persists. Why are all electrons identical? The properties of the wave, frequency, amplitude, shape, depend on the ocean itself. All waves in the same ocean follow the same physics. All electrons are waves in the same field, obeying the same field equations. The Dirac equation, discovered by Paul Dirac in 1928, describes the electron field. A relativistic wave equation combining quantum mechanics and special relativity. It predicts electron spin automatically. It predicts the existence of antimatter. When you solve the Dirac equation, you get energy states. Positive energy states correspond to electrons. Negative energy states, when properly interpreted, correspond to positrons. The equation does not allow for variation. It produces one set of properties, one mass, one charge, one spin. Every electron is an identical solution to an identical equation in an identical field. But this raises another problem. If electrons are identical and indistinguishable, can they affect each other even when separated? 1935. Albert Einstein works at the Institute for Advanced Study with Boris Podolsky and Nathan Rosen. They publish a paper in Physical Review on May 15th titled Can Quantum Mechanical Description of Physical Reality Be Considered Complete? The EPR Paradox. They describe two particles prepared in an entangled state. Measure one particle's position, you predict the other's position. Measure one particle's momentum, you predict the other's momentum. But position and momentum cannot both be precisely known according to Heisenberg's uncertainty principle. How can measuring one particle instantly determine properties of the other particle light years away without violating the speed of light? Einstein calls this spooky action at a distance. He argues quantum mechanics must be incomplete. Hidden variables must exist to explain the correlations. Local meaning no faster than light influences. Hidden variables meaning properties exist before measurement. Bell shows quantum mechanics violates this inequality. The prediction is testable. If experiments violate Bell's inequality, either locality is wrong or hidden variables do not exist or both. Nature must choose. They prepare pairs of entangled photons, measure their polarizations. The correlations violate Bell's inequality. The violation has high statistical significance. The result confirms quantum mechanics. 2015 brings loophole-free Bell tests. Henson and collaborators at Delft University use nitrogen vacancy centers in diamonds 1.3 kilometers apart. They entangle electron spins using a photonic link. The CHSH inequality, a version of Bell's inequality, is violated with S equals 2.42 plus or minus 0.20. The local realist hypothesis rejected with p-value 0.039. Justina and collaborators publish simultaneously using entangled photons with p-value much less than 10 to the negative 6. Shalom and collaborators do the same, adding random number generators to choose measurement settings. They use bit strings from Back to the Future, Star Trek Beyond the Final Frontier, Monty Python and the Holy Grail, Saved by the Bell, and Doctor Who to generate randomness. Every test agrees. Quantum mechanics wins, local realism loses. Measure one electron's spin along an axis. The other electron's spin along that axis becomes determined instantly, not because hidden variables existed beforehand, because the measurement on one electron affects the quantum state of both. This is not information transfer. You cannot use it to send messages faster than light. The no communication theorem, published in 1978 and 1979, proves this mathematically. But it is non-local. The correlations cannot be explained by any local theory. Electrons separated by the width of the universe can still be described by a single quantum state. They are not two separate things. They are parts of one quantum system. The carbon traveled through space, got captured by the collapsing gas cloud that became the solar system, got incorporated into Earth, got absorbed by plants, got eaten by animals, got eaten by your ancestors, got passed to you. The electrons in that carbon have been swapped countless times, traded between atoms in chemical reactions, moved through molecules, changed orbitals, but you cannot tell which electron came from where. You cannot track individual electrons through that history. They are indistinguishable. The electron in an oxygen atom in your DNA could have been in a hydrogen atom in the primordial cloud, or in a different oxygen atom, or in nitrogen, or in anything. There's no way to know. The electrons have no identity, no history, no labels. Hydrogen has 1, carbon has 6, oxygen has 8, iron has 26. Assume an average of a few electrons per atom. The total number of electrons in the observable universe, somewhere around 10 to the 80th power. Maybe 10 to the 81st. Every single one identical. Same mass to 1 part in 10 to the 9th. Same charge to better than 1 part in 10 to the 21. Same spin exactly 1/2. If the mass varied by even 1 part in a million, atomic spectra would shift. Chemistry would change. Stars would burn differently. We do not see this. Measurements across the universe at different times over billions of years show no variation. Scientists send current through a copper conductor. If the exclusion principle were violated even slightly, incoming electrons could transition into already occupied states in the copper atoms. This would emit X-rays with a specific signature. The experiment ran in 2011. Saw nothing. Upper limit on violation probability, 1 part in 10 to the 29th. VIP2 started in 2016 with better detectors. Still running. Still seeing nothing. The exclusion principle holds to 1 part in 10 to the 30th or better, the most precisely tested symmetry principle in nature. Particles with integer spin must be bosons, allowing multiple occupation. The theorem connects spin, an intrinsic property of each particle, to statistics, how collections of identical particles behave. The connection is not arbitrary. It emerges from requiring the theory to be consistent with both quantum mechanics and special relativity. If you violate it, you get causality violations. Effects before causes, negative probabilities, nonsensical predictions. The universe enforces the spin statistics connection absolutely. But the exclusion principle forbids this. Each electron must occupy a different quantum state. As you compress the star, you force electrons into higher and higher energy states. This creates a pressure. Electron degeneracy pressure. Not from temperature, not from particle collisions, from quantum mechanics. The pressure holds the white dwarf against gravity. No fusion needed. The star is stable. When Subrahmanyan Chandrasekhar calculated this in 1930, he found a limit, the Chandrasekhar limit, 1.4 solar masses. Above this mass, even degeneracy pressure cannot hold the star. It collapses further into a neutron star or black hole. A neutron star has 1.4 solar masses compressed into a sphere 20 kilometers wide, density comparable to an atomic nucleus. Neutron degeneracy pressure holds it up. The most extreme matter in the universe supported entirely by the identical nature and mutual exclusion of indistinguishable particles. This script uses sources from Physical Review C, volume 109, published February 24th, 2024, reporting Compton polarimetry measurements at Jefferson Lab with 0.36% uncertainty in electron spin, and from Springer's Journal for General Philosophy of Science, volume 51, published June 24th, 2020, examining particle indistinguishability and identity in quantum theory through the factorism interpretation. Back to the information. This is the singlet state, spin 0. If both electrons have the same spin direction, the triplet state, they cannot occupy the bonding orbital. They go into an anti-bonding orbital instead. The molecule is unstable. This is not because the electrons repel electrically. They do, but that is not the whole story. The antisymmetry requirement creates an effective repulsion called exchange interaction. It has no classical analog. Arises purely from indistinguishability and exclusion. It explains why helium atoms barely interact with each other, why noble gases are inert, why the entire structure of the periodic table exists. Measure one, you affect the other. This is the basis of quantum teleportation demonstrated in 1997 by Anton Zeilinger's group. They teleport the quantum state of one photon to another using entanglement, not moving the particle itself. Moving the information, encoding its state. Electrons work the same way. The state of an electron here can be transferred to an electron there without the electrons physically moving. Because the electrons are indistinguishable, because they can be entangled, because measuring one collapses the shared wave function. This is the foundation of quantum information processing. They put the atomic spins in a superposition of up and down, apply magnetic pulses, separate the spin states spatially, then reverse the process, recombine them, measure interference. The experiment completes the loop. Stern and Gerlach started in 1922. It shows the splitting is reversible. The atoms remain in a coherent superposition throughout. The interference pattern proves the process is quantum, not classical particles following definite paths. Wave functions evolving and interfering. Feynman calls it putting Humpty Dumpty back together. The achievement offers a new probe of quantum measurement and may help test gravity's effects on quantum systems. The two theories do not combine easily. Electrons have mass. They should curve space-time. But how does a wave function curve space-time? How does curved space-time affect wave function evolution? Nobody knows for sure. Attempts to build quantum gravity, string theory, loop quantum gravity, others, make different predictions. Testing them requires extreme conditions. Planck scale energies, microscopic black holes, early universe moments, inaccessible in labs today. But maybe indistinguishability offers a way in. If you can create a superposition of an electron in two places with measurable gravitational effects, you can test how gravity and quantum mechanics interact. The electron should gravitate toward itself. The wave function should feel its own space-time curvature. This is not science fiction. Groups are trying it. The technical challenges are immense. The payoff would be revolutionary. Not just nothing measurable changes. Nothing changes, period. The swap is physically meaningless. It does not correspond to any real transformation. Philosophers call this a permutation symmetry. The laws of physics are invariant under permutation of identical particles. This is deeper than other symmetries. Rotation symmetry says physics looks the same after you rotate your apparatus. Permutation symmetry says physics does not even notice you permuted the particles. The particles have no identity to permute. It is partly present everywhere electrons exist. In your body, in distant stars, in the entire universe, not in the sense of being smeared out, in the sense that the concept of a specific electron makes no sense. There are only electron presence and electron absence at various locations described by the overall quantum state. This conflicts with how we talk about particles. We say the electron in this atom or that electron in my detector. But that is linguistic convenience. The actual physics has no room for it. The moment they overlap, distinguishability is lost. But most of the time, in normal conditions, electron wave functions are well separated. Atoms are mostly empty space. Electrons in different atoms rarely overlap significantly. So practical distinguishability holds even if fundamental indistinguishability underlies it. Is the universe actually a quantum state evolving in Hilbert space? Or does the wave function represent knowledge, information about what we can predict? The indistinguishability of particles weighs into this. If particles genuinely have no identity, if permuting them is meaningless, then the wave function seems to be describing reality itself. There is no hidden layer underneath where electrons have labels. The quantum description is complete. Einstein thought otherwise. His EPR paper argued the quantum description must be incomplete precisely because it leads to paradoxes like indistinguishability and entanglement. Local hidden variables should restore a classical picture. Bell's theorem and experiments proved Einstein wrong on this. There are no local hidden variables. The quantum picture is correct. Indistinguishability is real. Entanglement is real. Non-locality is real. 2024. Scientists publish a paper in Science on structured electrons with chiral mass and charge. They convert free electrons into right-handed or left-handed coils using laser light. The electrons maintain a flat de Broglie wave, unlike vortex beams, but obtain chirality from the shape of their expectation value in spacetime. Measurements reveal three-dimensional coils and double coils with left or right pitch. This is not giving electrons different intrinsic properties. All electrons still have the same mass, charge, spin. The experiment changes how those properties are distributed in space and time temporarily. The electron returns to its normal state afterward, still identical to every other electron. The universe is 1.4 times 10 to the 10th years old. The electron lifetime exceeds the age of the universe by a factor of 10 to the 18th. Electrons are stable for all practical purposes, maybe forever. The universe will end before electrons decay, if they decay at all. The electron mass in the 2018 values, 9.1093837015 times 10 to the negative 31 kilograms with relative standard uncertainty, 1.7 times 10 to the negative 10. The 2022 values, no change to the recommended central value. Uncertainty reduced slightly. Measurements from particle accelerators, penning traps, atomic physics experiments around the world over decades agree within error bars. No evidence of variation with time, location, or method. The charge of every electron measured anywhere, anytime matches. Tests continue. The precision measurement of electron polarization at Jefferson Lab in 2024 reduced uncertainty to 0.36%, breaking the record from SLAC in 1995 of 0.5%. The measurement crossed the 0.4% threshold needed for the Mahler experiment testing the standard model. Every new precision test confirms electron properties are identical. Here's what this means. Take an electron from your hand. Take an electron from the Andromeda Galaxy, separated by 2.5 million light years. Both electrons were created in different events, at different times in different places. One may be in a supernova, one may be in cosmic ray collision. They have never interacted, they never will. But measure their properties. Mass identical to 1 part in 10 to the 10th. Charge identical to better than 1 part in 10 to the 21st. Spin identical exactly. Magnetic moment identical to 1 part in 10 to the 13. G-factor identical to 13 decimal places. How is this possible? Why does the Dirac equation produce exactly this mass, this charge, this spin, and no others? Why are the fundamental constants, fine structure constant, electron to proton mass ratio, elementary charge, precisely the values we measure? Change any of them slightly and chemistry changes. Atoms become unstable. Stars do not form. Life does not arise. This is the fine-tuning problem. The values seem suspiciously well calibrated for complexity to exist. A theory we do not have yet that predicts why the constants must be these values. String theory attempts this. 11-dimensional space-time compactified to 4 dimensions. With specific topology, produces specific low-energy physics. Depending on how you compactify, you get different particle physics. Our universe corresponds to one particular compactification, but string theory has 10 to the 500 possible compactifications. The landscape problem. No one knows which one is correct or why nature chose it. Meanwhile, experiments keep testing. The VIP-3 experiment at Gran Sasso will improve sensitivity to exclusion principle violations by another order of magnitude, expected to start 2025. We'll test if any electron anywhere ever violates exclusion at the level of 1 part in 10 to the 31st. Google demonstrated quantum supremacy in 2019. China achieved quantum advantage in photonics in 2020, all using indistinguishable particles, identical qubits, entangled states. If electrons were not perfectly indistinguishable, none of it would work. Quantum error correction depends on identical qubits behaving identically. One electron different from another by 1 part in a million would destroy coherence, ruin the computation. We see no such effects. Devices would fail. The entire foundation of modern electronics rests on perfect electron indistinguishability. The signal is strong because all hydrogen nuclei and water resonate at the same frequency. If protons varied, the signal would smear. Image quality would degrade. We see no such effect. Every proton in every water molecule in every tissue in every patient gives the same signal. 9,192,631,770 oscillations. Defined in 1967. Used until 2019, when SI units redefined based on fundamental constants. The transition frequency depends on electron and nuclear spins. If electrons in different cesium atoms had different properties, the frequency would drift, clocks would disagree, timekeeping would fail, GPS would not work. The internet would collapse. Everything synchronized to atomic time depends on perfect particle identity. Excitations in a single quantum field pervading all space-time, obeying the Dirac equation, following the exclusion principle, creating the structure of matter, holding up white dwarfs, enabling chemistry, powering technology, and we still do not fully know why. The identity of their physical properties is so far-reaching it results in complete indistinguishability. This is not a limitation of our knowledge, not an approximation, not a model. It is how reality works at the quantum level. Particles of the same type are fundamentally the same. Swapping them does nothing. Permutation is meaningless. The universe does not track which electron is which because there is no which. There are only states occupied and states empty. Fermion presence and fermion absence. Every test ever done shows perfect identity. No exceptions, no variations, no deviations. The more precisely we measure, the more identical electrons appear, down to the limits of measurement, beyond what we can currently probe, possibly down to infinity, exactly identical, forever. One strange idea rejected by physics, but accepted by poetry. Because in quantum field theory, in some sense, he was right. Not literally one electron, but one electron field, one quantum state, one wave function describing all electrons everywhere, entangled, correlated, inseparable. Your electrons and star electrons, parts of the same quantum reality, not independent things, modes of a single entity, the electron field of the universe, and you cannot change it. You cannot make an electron different. You cannot give it more mass or less charge or altered spin. It would not be an electron anymore. It would be something else, a different particle, with different physics, different chemistry, different universe. The electron is what it is because that is what the field is. That is what the equation allows. That is what nature chose when the laws of physics crystallized in the first instance after the Big Bang, or before, or outside time entirely, wherever the laws come from. Mass and charge flowing in three-dimensional shapes, measured by attosecond gating, revealing coil structure. But after the laser passes, after the field vanishes, the electron returns. Mass 9.109 times 10 to the negative 31 kilograms. Charge negative 1.602 times 10 to the negative 19 coulombs. Spin 1/2. Identical to every other electron. Again, always, forever. Identity reasserting itself no matter what you do. Because the field demands it. The equation requires it. The universe enforces it. Fundamentally, completely. The same particle repeated 10 to the 80th power times across all of space. Same properties, same statistics, same quantum field. One type of electron, perfect copies. Indistinguishable until the universe ends.